So we move on now and we start talking about the environment and sustainability. We said before these are the main themes for this event, and we will start with Professor Michael Spath. Hi, Michael. Michael is Professor of Environmental Studies here at BMCC. He is also the Health Safety Officer and the Campus Risk Manager. And today we will hear more about the current environmental issues in Italy. Okay. Hi, Michael.
Hi, good morning, everyone. Let me share my screen here. All right, some environmental problems Italy faces today. I get to be the gloom and doom. Everyone else gets to talk about all the wonderful ways Italy's trying to solve their problems. I get to be Mr. Gloom and Doom as usual and tell you about the problems to begin with. All right, Italy has some very unique challenges as far as environmental problems go. Challenges that as an American environmental engineer, I would never dream of having to face. And this is one of them, the Libiola copper mine. You can see this is up near Genoa. And it is right by the Ligurian Sea. It's a very strategic place. You can see it's by the coast. For ancient times, it was in a perfect spot to be able to get copper and ship copper throughout the region. And that is one of the main problems with this. There are wastes from that mine that are between 335 and 230 meters up in height, elevation, that are about half a square kilometer. And unfortunately, two tributaries of the Gramola River cross right through it. You can see a little map I drew here. This is where the site was. And you can see there are a couple of rivers that pass right through the debris field and unfortunately exit right into the sea. So anything that was left, all the mine tailings and waste that was left here, all the materials in it are going to leach out. They're going to go out of the rock. They're going to go into the water. And unfortunately, that now contaminated water is going to go all over. Help a little bit if you guys understood how we get this ore into copper. All right. Basically, what you do is you crush the copper ore. You take the rocks and you crush it into as small a piece as possible, and you actually spray acid over it. Right? The acid will take metals, all the metals that are in the rock, not just the copper, but there are other metals that are in there. And it's going to take it to this pool. And in this pool, you've got underneath, you've got copper that's dissolved, and you got acid, which can go back in. Right? The problem is, like I said, this blue layer has more than just copper in it. And to make matters worse, these acidic wastes, the way they were acidified, makes the waste what we call in this field mobile. Mobile means it really wants to jump out of the solid and go into water and pollute the environment. Right? It's not something that's going to stay there and want to be happy living in the rock. It wants to get out and it wants to take a walk. Now, here's the issue that in America, we would never face as an environmental engineer. This mine's been in operation since the Bronze Age, roughly 4,500 years. They have been mining copper there. Modern techniques using chemicals, the acid spray that I showed you, have actually been used since the 1600s. And that was done all the way up until the mines were abandoned in 1965. All right, so in 1965, thank God, they stopped production at the mines. They stopped making these harmful products. The only problem is the first environmental laws in Italy were passed in the 1970s. After the mines ceased operation. So what we call the tailings, those are the waste rocks and the waste when you're done mining the metal you want. They were already produced, they're already out into the environment, they're already pushing their metals from the rock into the environment before Italy even passed their first environmental laws. So the damage was done. The laws came into effect a little too late to help. This is the composition of those waste rocks I talked about. All right, it's chemically, it's engineering. Yes, as an engineer, I love stuff like this. But just to highlight for you, I drew some blue arrows on the metals that are extremely toxic. All right. Copper, believe it or not, is a toxic metal. Copper is used a lot if you have paint or if you have a tent and it's coated with any antifungal. It has a compound on it. I love the way this compound sounds, so I'm going to say it. Copper quinolinolate is the name of the compound, and that is actually an antifungal and an anti-moss. Copper is a good antimicrobial agent. It's toxic. So is nickel, chromium, arsenic, selenium, and lead. Those are all very, very toxic metals, and you can see that's what was in the waste rock that was left at these mines. All right, the problem with that is when these metals get out, it really wreaks havoc on the general environmental quality in the land region. All right, you've got metal uptake. Plants like to take it up. The ground fish, the freshwater fish, will absorb a lot of these minerals. But it gets worse when we talk about the sea, the Ligurian Sea, which is right there, because the metals wind up in the sediment, and then we get what's called bioaccumulation up the food chain. Right, the very small animals are feeding down near the sediment, the plankton. So each plankton takes in a little bit of this metal. The problem is then the small fish eat a lot of plankton. So the metals from 100 plankton or 1,000 plankton wind up in this little fish. The bigger fish is going to eat 20 of the little fish. So now you've got 20,000 plankton metals in the bigger fish. One bigger fish eats that. Now you're up to a couple of 100,000. And then that's the kind of fish, the tuna, the octopus, the squid that we're going to eat. And by that point in time, you've got 1 million times the metals from a plankton in that food. And that's what the humans would eventually consume. So it has a pretty big impact. I would be remiss from my family. I believe I would be disowned if I did any talk on Italy without going into probably what we consider the greatest part of Italy, because that's where we're from, Sicily. And Sicily has a big petrochemical industry. And I want to talk about some areas in Sicily, 3 of them, that have some oil refineries and some problems with them. Sicily is the trade hub of the Mediterranean. It has always been. It's major ports. It has shipping. Ever since the age of the earliest ships, the trimaraners, Sicily has been a hub. People have traded. It's gone in. It was referred to as the crossroads of the Mediterranean. The problem with being a major shipping hub is when you transfer material between ships and containers, you cause releases into the environment. We know ports are not the cleanest facilities ever made. The second issue that comes up when you have a really good shipping hub is you have a plethora of industry that pops up. Raw materials are coming in here. This is the easiest place to get raw materials. Your crude oil can be brought by ship and unloaded dockside to a facility. That's where you're going to want to put your crude oil refineries. All right. Newark also has a large refinery presence just for the same thing. If you've ever driven or gone into Newark International Airport, you see what we call Cancer Alley, the lovely set of the 3 refineries that are right by the Newark Airport. And when we talk about Cancer Alley, that's exactly what happened in Sicily. There was a cancer cluster. Right? So the mayors of the villages, Milazzo Delamere, they asked WHO, the World Health Organization, for some help. And they came in and they did some risk analysis and they did some studies of these areas. And they did find some interesting things. When we talk about petroleum refining, I'm a chemical engineer, so if I get a little too technical, I'm sorry. This is our bread and butter. But there's a lot of things that have to go on when you take oil. Crude oil looks like mayonnaise. If you've ever had the opportunity to see crude oil, it literally is the consistency of mayonnaise. And before it turns into gasoline, oil, cosmetics, and all that other fun stuff, a lot of things has to happen, right? We have to take salt out, we have to distill it, we can reform and extract metals from it, and then we recover the waste. There's lots of contamination involved from before these laws were passed, releasing chemicals directly into the environment. If you have a system where you don't have strong environmental laws or a lot of oversight, you get poor control systems. All right, that's my area of expertise, is making pollution control systems. If they don't work, the materials go right through. And obviously, we make a lot of toxic substance. This is what the refinery looks like at Augusta. All right, this is typically what an oil refinery looks like. This is not an unusual one or a different one from any way, shape, or form. This is what a normal oil refinery looks like. Why do we love these things? Why do we keep building these things, you would ask, with all these problems? Because crude oil is broken into just about everything we use for our infrastructure. Any kind of fuel, all plastics, road wear, lubricating oil, your cosmetics, medicines, everything gets its start from crude oil. Without those factories, none of these things are possible. There's a lot of impacts, though, when you process petrochemicals. All right. A lot of stuff goes into the air. We call it atmospheric distillation. If I can go back, you can see there's some exhaust plumes going on. All right. This is vented to the atmosphere. When you vent to the atmosphere, all of these things which are contained in oil, all right, ammonia, particulate matter, volatile hydrocarbons, those are the chemicals. If you've smelled gasoline or paint, that chemical smell you get off of it, those are volatile hydrocarbons. All wind up in the air along with metals and spent acids. So all of this is being pumped into the air, which eventually is going to settle on the land and the water. We use a lot of water when we distill, cooling water, processed water. The problem is a lot of that does pick up some waste. And unless you treat that water properly, you're going to discharge the waste right into the surface water, or in the case of these seaside refineries, usually right into the water. And we do take a lot of cooling water. You need a lot of cooling to chill this stuff down after refining, and we can't use the salt water. Salt water is too corrosive on the equipment. So we use a lot of the fresh water that would normally be available for people in farming. A lot of that goes into our cooling towers to cool down the stuff. Lots of solids. There's sludge and catalyst. I told you that crude oil, if you've ever looked at it, looks like mayonnaise. Well, obviously, when we're done, the bottoms and the tailings are very sludge-like. It is a very tar-like substance that comes out the bottom of these things. We also have different sludges from the processing. We do need catalysts. We all like gasoline, so chemical engineers cheat. We change the crude oil a little bit as it's going along to give us more gasoline and less other stuff. We use catalysts for that. Unfortunately, when we're done, the catalysts are now toxic waste, and we got to find a safe home for them. And we have other problems. There's leaking. I mentioned that when you pump materials around or you transfer containers, you get spills. And if you've ever looked at the shore around New York City, you'll see that nice rainbow sheen on the water. That is spilt hydrocarbons from either the boats or fueling or just oil that comes out of the boats as they go along. So those are two of the problems, and two problems that we would never have because America has not been around as long as Italy has. So most of our mining operations, although we've had some that are hundreds of years old, we have nothing that's thousands of years old to pump that kind of pollution out. And you have a transportation hub that has pretty much been in existence since the beginning of ships. And at the beginning of industry, even before industry, when we're talking about just artisans making these materials, no one thought anything of environmental conservation problems or preserving it. They just took their stuff and put it on the land, the waters carried it away. That was fine up until a point. And now we've reached that point and some stuff has to be done. And you're about to hear about all the fun stuff that Italy is doing to make it better. So there you go.
Thank you, Michael. That was very illuminating for myself, and I'm sure a lot of our students. I think, we've all heard about the dangers of fuel, but some of your images, I think, really brought that home. So thank you very much, and I appreciate the historical perspective on the 4,000-year-old port by Genoa.